Alright, so what we're going to try to do here is we're going to be talking about if something is a function or not a function. Okay, and we have a thing called a relation, just like kind of a relationship. And you have what's called a input versus an output. Okay, and we have a couple of relations here. So we have what's called ordered pairs, which you guys should be very familiar with. Okay. So the x value is what we call the input. The y value is what we call the output. Okay. Then you can refer to this in a table. So in this table here we have giraffes. Okay. So if you wanted to, you could probably call that the x value, right? Or the input. So you input the age and out comes the height. And then you can also refer to this in a graph. Okay. Or the third thing is what we call a mapping diagram. All right. And we refer to these as the x value, and we have a couple of different names for it. One of the names is called domain, and down here I have a bunch of, so we could call it the domain, or the x value, or what we call the input, when we input something, or sometimes we call it the independent variable, okay? So again, all the x values, and you'll notice we put them in numerical order. So we have 14, 16, 18, and 20. Then the range is the output, which is the y value, or the dependent. And again, we put the y values in numerical order, from the least to the greatest. Okay? And the reason we call it dependent is if you look at it, if you look at this, and you're talking about the height, your height depends on how old you are. Okay? So that's why it gets the name dependent variable. And independent is kind of on its own, okay? It doesn't depend on anything. All right, so let's take a look at what we are calling a function now. So a function is a special type of relation in which all the x values, or the input, is exactly paired with only one of the output values. All right? So it's pretty easy just to look at the difference. So we have an ordered pair here. So all you're doing is you're looking at the x values, right? And you're seeing if we have anything that repeats. And you'll notice here we have nothing that repeats. So for every input, we have a special output. Now you notice some of the outputs repeat, which is fine, okay? You'll still have a function. But the input or the x values cannot repeat. And then you'll look at an example of this one. It's not a function. And the reason it's not a function is because you have 0, which is our input, has two different outputs. So what I like to look at is I just look at the x values, and if I see something repeating with a different output value, then I know it is not a function. Again, we could look at a table. So if you look at this table here, iguana lengths, we don't have a function because 4, the input, has two different outputs. This one, this iguana at age 4 has 37 inches. And we have another iguana that's 4 years old that has 40 inches. So that would not be a function. However, in the next table of the giraffe heights, you'll notice that none of the inputs, or the x value, the age, repeats. They all have 18, 16, 20. They're all different. Okay? So one output for every input would be a function. Now these are still all what we call relations, because relation is just an input and an output. And a function, again, is just a special type of relation. Okay? Now let's look at a couple of different things. Now graph-wise, you can easily tell. Let's look at the different graphs. We have what's called the vertical line. So if you can draw a vertical line through the graph and you hit it more than one time, then it is not a function. Not, okay? So if you look at the first example here, it's a function because if I put a vertical line anywhere through here, I am only hitting the graph once. Whereas in the second example here, this circle, you notice, I am hitting the circle more than once with the vertical line. And what that is telling me is if you look at the ordered pair, so let's say that is what? That's -2, right? So -2 looks like it has an output of 1, 2, 3, 5. And also here -2 looks like it may have an output of -5 or something of that sort. So that is not a function. Okay? This third graph is a function. And we will have names. So this is actually called a cubic function, which we'll be going over later on in the year. Okay, this fourth graph does not pass the vertical line test, right? Because it's hitting the graph more than once. And then the last one here, this fifth graph, vertical line test, it passes. Okay, so that's a function. So visually, you could tell right away when you're looking at a graph it's a function or not. All right, and then what we have, the last thing is what we call a mapping diagram. All right, and all you really need to do is just look at the arrows. So you, for instance, on this one, each of the arrows on the input, not the output now, just the input, goes to a separate output, okay? So that's a function. Whereas in the second example here, so the first one's a function, in the second example, you'll notice that we do not have a function because the number 2, the x or the input, has 2 separate outputs. So if you put that in an ordered pair, you'd have 220 along with 240. So you have what's called a repeat. Or sometimes I call it a cheater. 2's cheating, right? It's got 20 and 40. So that is not a function. Okay? So that is basically what we call a function. Let's look at a couple of verbal ones now. All right, and this is my last example. Let's take a Social Security. I don't know if you're familiar with what your Social Security number is. If you do know what it is, do not tell anybody because they can steal your identity. Okay, so, but a Social Security number is a special number that they give you. Usually when you're born, they'll give you a Social Security number. And each Social Security number is separate. Okay, so for instance, 333-33-333. Now that's not my Social Security number. Okay. Oh, there's one more number there. Okay. That's typical Social Security number. Okay, but everybody has a different one. So that's a function because there's no 2 Social Security numbers that will go to different names. But if you look at it backwards now, name, Let's take a common name like John Smith. All right. Well, John Smith could have one social security number, but there also could be another John Smith, right? Because we all know everybody. Most of us, if you ever Google your name, don't you see that there are many people with your name? Unless you have a unique name, of course. Okay? But something like John Smith may have two separate numbers, so it repeats. So that's why it's not a function. Okay? So that is the beginning of our lesson on functions.